Welcome to the Explainer. Today, we're going to decode the absolute cornerstone of data, the SQL SELECT statement. Seriously, if you've ever wanted to pull information from a database, this is where it all starts.
You use a special language, SQL, which stands for Structured Query Language. And really, it all comes down to learning how to build the perfect question, one clause at a time.
Okay, so here's our game plan. We're going to start with the basics, just asking the questions. Then we'll actually build our first query. From there, we'll get into filtering and sorting with some real precision, and we'll wrap up with a couple of pro tips to make your queries that much smarter.
All right, let's dive right in. The best way to think about a database? It's like a gigantic, perfectly organized library. The select statement, well, that's you, walking up to the librarian and asking for specific books. It is literally your window into all of that data.
Now here's something absolutely crucial to get. Select is non-destructive. What does that mean? It means you're basically just asking for a photocopy of the data. You can look at that copy, do whatever you want with it, but the original files, they stay in the cabinet, totally safe and untouched. You're not changing a thing.
Okay, so knowing what select does is great, but knowing how to actually build the query, that's where the real magic happens. So let's check out the essential blueprint.
Think of this as the basic grammar of SQL. You have to write your query in this exact order, every time. You start with select, that's where you pick the columns you want to see. Then, you use from to tell it which table to look in. After those two, you can add a where clause to filter the rows, order by to sort the results, and finally limit to say how many rows you actually want back. Don't worry, we're going to break all of these down. But just remember, to get started, all you really need are select and from.
So to make this all a bit more concrete, we're going to be using this simple students table for our examples. As you can see, it's pretty straightforward. It's got student names, a faculty ID, and their GPA.
And here we go, our first query in action. It can be just this simple. All this is saying is, hey database, from the students table, please just show me the last name and first name columns. And that's exactly what you'll get back. Just those two columns for every single student.
Now, I know it's super tempting to use this little shortcut, select everything. That asterisk just means select everything. But trust me, this is a classic trap. Why? Well, imagine someone adds a huge new column to that table later on. All of a sudden, your query is dragging back way more data than you need, and that can really slow things down or even break your application. So being specific, it's always the smarter, more efficient way to go.
Okay, but what if you don't care about every single student's faculty? What if you just want a clean list of which faculties are in the table? If you just select the faculty ID, you're going to get a long list with a ton of repeats. But if you add that little keyword, distinct, you're telling the database, hey, just give me the unique ones. And boom, no more duplicates.
So grabbing whole columns of data is cool, but the real power comes when you can zero in on the specific rows you care about. And for that, we have the where clause. You can think of it as your high-precision filter.
So how does it work? Well, the where clause applies a test. It's called a predicate to every single row, one by one. If a row passes the test, if the predicate comes back as true, then great, it's included in our results. If it fails, it just gets left behind. Simple as that.
And here are the tools we use to build those tests. And they should look really familiar. They're basically the same comparison operators you learned in math class. Equals, not equals, greater than, less than. You get the idea. We can use these on pretty much anything. Numbers, text, dates, you name it. And you know what's great? SQL gives us these awesome shortcuts to keep our code from getting messy. Instead of a long chain of OR conditions to find students from a few different faculties, you can just use the IN operator with a simple list. It does the exact same thing, but it's way more efficient and a whole lot easier to read.
But what if you're searching for text and you don't know the exact spelling? Well, that's where the like operator becomes your best friend. It lets you use these special wildcards. The percent sign, percent, matches any sequence of characters, and the underscore, underscore, matches exactly one. This is so useful for searching for things like names or titles when you only have part of the word.
All right, so we've picked our columns, we've filtered our rows, we have the right data, but it might just be in a completely random order. So let's talk about how to organize it and make it look good.
This is where order by comes in. It lets us sort our results. Now, by default, it sorts in ascending order. So, A to Z, or lowest number to highest. But what if we want to see the top performers? We just add the keyword DSC for descending, and it flips the whole thing around.
But hey,
A full sorted list could still be thousands of rows long. What if you only care about, say, the top 10?
Easy. We just add a limit clause right at the very end. The database does the sort first, and then it literally just cuts off the list after the number you give it. This is incredibly useful for things like leaderboards or any kind of top 10 report. Okay, let's finish up with two really powerful techniques. These will seriously level up your SQL game, making your queries not only more capable, but a lot easier for other people and you to read. So check out this question. How do we find students with a GPA that's higher than the average? This is kind of tricky, right? Because we want to find students who are above average, but we don't even know what the average is yet. We need to find that out first. The way you'd probably think about solving this is in two steps. Step 1. You run a query just to calculate the average GPA. Let's say the answer comes back as 3.85. Okay. Step 2. You take that number and write a whole new query to find all the students with a GPA greater than 3.85. But there's a much cooler way. A subquery lets us combine both of those steps into one elegant command. You literally just embed that first query, the one that finds the average, right inside the where clause of your main query. The database is smart enough to run that inner query first, get the average, and then it immediately uses that number to filter the students. It's super powerful and way more dynamic. And last but not least, let's talk about aliases. By using the keyword AS, you can give a column a temporary, friendlier name in your final results. So instead of your report having a column called last_name, all lowercase with an underscore, it can just say last name. Nice and clean. It doesn't change anything in the actual database, but it makes your final output look so much more professional. So when you put it all together, select, from, where, order by, limit, these aren't just random commands. They are the fundamental building blocks for having a conversation with your data. And now that you have these tools, you have the power to do more than just look at information. You can start asking real, meaningful questions and begin to uncover the amazing stories that are hidden inside.